In this video, we are going to look at the concept of diamonds. Now, diamonds are a special kind of polygon. Well, they're just a quad polygon, but they're arranged in a very specific way. And diamonds can help you with a ton of different stuff. They can help you when you split your edge flow. So when you're trying to maintain edge flow around a shape, and you might need to split two flows off in different directions, the diamond is going to help you out there. And it's also going to help you when you are trying to create these evenly distributed surfaces like we have here. Now, we have two diamond polygons in this piece of geometry. We have one here and we have one here. Now, these are doing two very specific jobs. So first off, I have an edge flow going around the top here, which I was trying to establish in the first place, and an edge flow that runs across the bottom. Now you can see that my first diamond is situated where these two flows split, here and here. And this diamond is facilitating me being able to split these two edge flows off in different directions. Now, another outcome of the diamond is the fact that I can actually increase my geometry on the other side of this diamond. I've started here with two polygons, and after my first diamond here, what I have now is essentially a row of four polygons. Now, I've done the same thing here with this diamond, and this is because this surface is getting kind of larger over here, and I want to keep my polygon size pretty similar. So again, I want to ramp up the amount of geometry in this area, and using another diamond to do this is working out pretty good, because now I have a row of 6 polygons after my second diamond. So every time I add a diamond, I get 2 more rows of polygons, and I'm able to establish an even size over this whole surface area, from it being very small to pretty large over here. Now, without using these diamonds to split this flow and essentially create more geometry like we have here, your topology may end up looking something like this, where it's all a bit blocky. Now, this is actually shrink wrap 2, but you can see we don't really have enough geometry to get a decent result here. And what we essentially have is 2 rows of polygons that are getting bigger in size. And this is not optimal. Might be fine on a flat surface. Obviously, flat surfaces are a lot more forgiving when it comes to the kind of topology you create. But when it comes to deforming or bending, curving your geometry, it always pays to have an evenly distributed surface. And this is pretty much the beauty of diamonds, and you're going to be using these a lot. They crop up a lot in retopology, and just when you're trying to create a surface that you can deform well using either deformers, or you're trying to create some geometry that's trying to move around a curve, and you may be doing this by hand. And a diamond is always a good way to ensure this is going to work out. And you'll start to notice this kind of like 3 polygon scenario that we have here. This is pretty much associated with the diamond. Obviously, we have another one here. And it's actually not dissimilar as well to the topology you see with a spin edge. So let's have a look at a few examples of how the diamond is going to help you out. So here's a pretty good example of how this might work. I have this mantle clock here. And say I'm thinking about modelling this. Maybe I'm just trying to go through and figure out what my edge flow is going to be. Now you can see here I have 3 very distinct lines going across this shape. The outside edge is obviously following this curvature, and I want to keep this as a single edge flow with no interruptions along this edge. I have another one that's going round this clock. I may not actually need this, as you know, all these features might be separate objects added to the front of this, but I'm putting it in anyway. And I obviously have an edge running down this flat edge at the bottom. Now, in amongst all this, I have this kind of extruded feature here, and I need to consider this if I'm going to integrate it into the mesh. It doesn't really look like it's stuck on. It looks like it's very much been routed out of this wood. So I'm going to need another flow around this feature, which I have here represented in blue. So now I have even more curvature I need to think about. I need to think about how much geometry is going to achieve this curvature. And then I need to think about how this curvature is going to attach to my green edges. And we can obviously see here that both of these green lines are flowing down either side of this feature. And in fact, this is happening on all three corners of this feature. Now, where these flows are splitting, we are essentially going to need to add a diamond into these areas so we can split the polygons either side of this feature. Now, actually, the best way to model this is to actually start with this feature, as it will give you a good gauge of how much geometry you're going to need. So in your project folder, you will find an image called mantleclock.png. Just drag it onto your front viewport, and then we can just bring the transparency down to about 90, which will let us see our geometry a bit better over this bright image. And let's zoom in to this feature. Okay, so let's build this feature. Let's grab our polypen tool, make sure we're in point mode. Now, the reason I use point mode is that it allows you to start with an initial polygon, and then you can just copy out using Command or Control on PC to create new polygons, and it's a pretty fast way of working with the pen tool. So let's start down here. Let's add a polygon on this corner. Now, the other reason we want to use a quad on each of these corners is because that's how we obtain sharp convex detail. And these would obviously be box cut to create this sharp corner. So let's copy out another edge here and then follow the flow up this side. Now, immediately we can see we have a split flow scenario here. So probably a good place for a diamond. Let's continue this edge along here. And now let's build this corner here. So again, you can see we have another kind of split flow scenario here. So let's chuck another diamond in here. Now we can kind of see this kind of topology take shape. So now we have 3 edges here, 3 edges here. So now we can just bridge in with the polypen tool. And that should pretty much do us. We have enough edges here to support this curvature. Now I may want to just make sure these are a bit more evenly spaced. Maybe spend a bit of time lining these up. And I could grab my brush tool in smooth mode. First select the outside points, UI invert. Grab my brush tool, smooth. Just smooth out these points in the middle. And that should be us good to go. So here's a good example of how this kind of diamond here, just how this is changing these 2 edges here into 4 edges here. And then this 4 edge scenario is rolling up this shape all the way to the end. And we're getting this nice even distribution across this shape. Now here's where the beauty of all this sort of comes in. If I grab a disc, put this Z minus, so the polygons are facing towards us. And let's put the radius out, and let's match it up with the curvature of the shape we just modelled. So now what I can do is just adjust the edge segments. So let's go with 28 here. I've got 4 polygons kind of in this area, and I reckon this should work out pretty good. Now I'm going to expand this out so the disc is creating my curvature around here. Let's give this one segment and then bring my inner radius out to about here. And this is what I'm going to basically work with. So let's make this editable. Now I'm going to put this into symmetry, obviously, so what we should probably do is just get rid of this half. Just optimize. And now we can start to think about splitting these flows up. So the general gist of it is, let me get my pen tool, go into point mode, is I would start moving this geometry out like so. I don't really want to do that because I don't want this to start happening. You know, where everything starts getting stretched out and stretched out. I want to keep control of this. So what I'm going to do is grab these polygons up to here, knife tool, loop mode, and I'm going to cut through here. I had restrictor selection, so it's only cut the polygons I selected. So this is where I can actually start to split this up. So I'm just going to cut away that Engon line and then cut into this edge here, which should give me a point here. Turn on snap. Just snap this edge up here. And then I can start moving these edges down like so. I just snap these points to here. Now over here I can do pretty much the same thing as I did on the other corner. Let's cut into there, cut a point in. Let's grab our poly pen tool. So poly pen, let's snap this in. Like so. And at this point what I probably want to do is join these two together. So let's go connect objects and delete. Do an optimize. And we may want to put our tolerance up a little bit so everything welds together. You can see these points haven't quite got there. And now what I could do is probably just grab these edges, copy these down, scale to 0, let's optimize again, scale these to 0. And then I can just kind of copy out this edge, optimize, and then just bring these edges down like so. Join up with my bottom edge. And there I have pretty much the basics of this geometry. Put that in a symmetry, and then for my extruded feature here, obviously I can take these polys, extrude out like so. I could even inner extrude this to obviously create kind of beveling we're seeing on that feature. So the cool thing is that we have our extrudable feature, but we also have been able to maintain all of the edge flow that we wanted by splitting this flow up using these diamonds where our flow split, and using those diamonds to give us a nice even poly count across this surface. So this would be a very good starting point for this model. So here's this clock with a little bit of cleanup. Done some sharpening here and some beveling, and what you get is a fairly nice result. And this is all pretty much due to our base geometry just allowing all this sharpening to happen. Take off the subdivision. See some very simple solid chamfering going on here. Some kind of borrowed edge stuff going on here, slightly different topology wise, where this flow is splitting. But this would be the same on every single corner. Pretty standard stuff. I'll leave this in the project file so you can have a look. So in the next video we're going to build some simple shape examples, and we're going to integrate the diamond into our surface topology so we can keep it nice and even across the board.